All right, so today we're going to take a look at parameters of exponential functions. Before we do, we're going to take a look at a real life situation. All right, so these are some roller coaster rides, and I'm just going to show you that they are indeed exponential functions. So if you look right here, this is a decay one, right? All right, if you look at this one, this is also a decay one. Now, the question I'm going to start asking is which one is steepest? All right, so which one looks steeper to you? All right, so I'm really scared of roller coaster rides, and so I'm definitely not getting on this. I'm not getting on anyone, but in terms of math, right, I'm definitely not getting on this one. Why? Because I'm falling so much faster than I am on this one or this one. So this one is the steepest one. Steep. Okay, so you don't need to write this down. I just want to visually show you before we start our work. All right, then between this one and this one, which one is steeper? All right, so let's take a look at it again. So this one is falling like that. So look at the curve. Look at where we're starting, right? If you're sliding down this roller coaster like that versus sliding, look, already I'm more vertical than I am on this one. This one's starting more on an angle. All right, so this one has a little bit of an angle, whereas this one is more vertical. So what you're going to remember for the work that we're doing, the closer the roller coaster slide exponential function is to being vertical, which means straight up, the steeper it is. The more curvy it is, the further away from it being straight, like so it's doing this, the more curvy it is, the flatter it is, the less steep. All right, so looking back at parameters of exponential functions, it says example 1. Function A, the area of the wall that's covered by mold A in square inches, it's doubling every month. So I'm just going to underline that keyword so I can just remember it. Function B, the area of the small wall that's covered by mold B in square inches is tripling every month. So one is doubling, one's tripling. So just to make sure, doubling is meaning that you're multiplying by 2 every time. Tripling means that you're multiplying by 3 every time. All right, so example 1, which graph represents each function? So you know function A is doubling, function B is tripling. So this one is steeper than that one because it's growing by triple the amount this one is. So it's growth. So instead of it going down, decay, it's growth going up, right? All right, so which one is steepest? Because that is going to be function B. So pause the video real quick and give it a shot. All right, so you should have said, right, this one, this line right here, this is the steeper one. So remember my definition of my roller coasters, right? The closer it is to being straight up and down, the steeper it is. So in the beginning, they both look like they're going at the same rate, right? This way, well, they're going pretty much the same this way. But as you get here, this one is a little bit flatter because this one is getting more vertical, okay? So the more vertical it is, the steeper it is. That means that function B must be the tripling one. Therefore, this one has to be function A. All right, so we've labeled the graph. Now we need to explain our reasoning. So why did I say B is a solid line? Because our rule is going to be the steeper or the more vertical. Let's do that. The more vertical the function, the steeper it is. So B is steepest. Okay, so just remember whether it's growing or decaying, the one that's most vertical is the steepest. All right, 1B, the mold was first spotted and measured. Was there more of mold A or more of mold B? So what does that mean? When I first started, before any time had started, so when I first started, my initial value is always where X is equal to 0 before I even do anything. So what is the y-intercept here? This one is less than this one. So was there more of mold A or mold B? There was more of the dotted line, which is mold A. So explain how you know. Mold A, dotted. Mold A's dotted y-intercept is higher. Okay. What does the point tell us in this situation? Oh, what does the point PQ tell us in this situation? All right, so this is the point PQ. Looking at the point PQ, what can you tell me? That the dotted line and the solid line are exactly the same. So in this situation, because now I have to use this word, this problem, at the time P, because that's X, and at the area Q, they're exactly the same. So the area of the wall that's covered by both mold A and mold B is exactly the same at the same time. Okay, so we're just going to write that down. What's it saying? The area that is covered by both, right? Both, because it's exactly the same, mold A and B, and you can just use the space right here, is exactly the same, or you can say is equal, exactly the same at time P. So basically, that's just in words. What is that saying? That is saying that at this very spot, both the dashed and the solid are exactly the same. P and Q are the same for both graphs. That's what that's saying. All right, so that's example 1. Okay, so you can go ahead and do example 2, because it's the same thing, only instead of growth, it's decay. Just remember again to tell which one is decreasing faster. The one that is more vertical is steeper, right? And is going down faster or going up faster. It doesn't matter the direction. So go ahead and try example 2. I'm going to do example, actually it doesn't matter. Let me do this one. Example 3, you do example 4. All right, so here are the graphs of two exponential functions. So we have f and g. If f of x is this and g of x is this, what could be the value of b? So you can definitely type this into Desmos. In fact, you can type this one into Desmos if you want to, but I'm just going to do this without typing it in. So let me look at it. So first of all, both of these graphs are what kind of graphs? Are they growth or they decay? They're decay. That means that my b, if it's decay, my b should always be what? Between 0 and 1. So if it's greater than 1, it's not decay, it's growth, right? So I can immediately cross this out, because if you put 3 divided by 2 in the calculator, you're going to get 1.5, and that's going to be growth. So that's gone. It's not 1, because 1, actually, you see how this says strictly less than? It does not have this equal to underneath. So it cannot equal 1, because what happens is when you multiply a number by 1, it does not grow and it does not decay. Okay, so that's what that means. So immediately I'm down to 2 numbers. Okay, all right, so now their fraction is 2 over 3. Okay, so if I look at f, so this is f is not as steep as this one. So this one, g, is steeper. Now with fractions, decay is a little bit more challenging. With growth, it's going to be obvious. With decay, you're going to notice, and I'm going to prove it first in the calculator before I tell you the answer. I'm going to give you different fractions. So let's say we have 1/2, which is 0.5. We have 1/3, which is 0.33. Let's make one that's even smaller, 1 divided by 8, which is 0.125. So I'm just putting from greatest to least, right? So 0.5 is bigger than 0.33, which is bigger than 0.125. Now, let's see what happens when I put those graphs, because with decay, it's just a little bit different. So remember, my equation is y equals a, which is my y-intercept, b, which is my growth or decay, raised to the power of x, which is my time. Okay, so I'm going to take this equation and make an equation showing you decay with all of these fractions. So I'm going to do it 3 times. All right, we're going to give it all the same a, because it doesn't matter what the a is. In fact, let me make it something that's going to be up here on my graph really quick. All right, so all the a's are going to be the same. And what I'm going to change is the b's so you can see the steepness of it. So I'm going to go from greatest fraction, which is 1/2, to second greatest fraction, which is 1/3, to third greatest fraction, which is 1/8. All right, so again, okay, we're going to zoom out a little bit. Right, looking at which one is steepest, right? This one is steepest, is closest to being vertical than all of this. So the green one is the steepest. But when you look at green number, 1/8, is that the greatest number? No, it's actually the smallest number. So with fractions, it's going to be opposite of what you think, okay? The steepest one is going to be the smallest fraction. So if that's the case, it should go green is the most vertical. Then this one, which is blue, should be the second vertical. And then the red one should be the flattest one. And you can see that. So this one is more vertical than this one, and this one is the least vertical. All right, so again, with the fraction, it's going to be opposite. So the smaller the fraction, the steeper the graph. That's what I need. So I'm going to go ahead and write those notes right here. And I think I read it somewhere else, but we're going to write it right here. So the steeper the decay, the smaller the fraction. And it's actually going to be opposite for growth. Growth is going to be exactly what you think. So you can do this either by hand, now that I've just told you that, or by calculator, but go ahead and do that question. Let's practice.